Yes, students. Elasticity, second part of the day. Stress. What?
Stress.
What?
Stress.
Stress is what? To understand stress, first of all, when we talk about stress, immediately we recall PTM. Teacher encounters parents and student report card is being handed over, and the teacher says to the parents, your child is not feeling much stress of the studies. He's high, he should put stress at the studies. You might be listening in some lectures, I stress on this point. I ought to stress on this point. Students, this word stress in day-to-day life is not the same in physics. Stress is kind of a physical quantity which is like pressure. Which is like
Pressure.
Focus please. Limit. Which is like pressure. But it's not like pressure. Its dimensional formula is like pressure, force upon area. Its unit is same as pressure, Newton upon meter square times upon centimeter square. But in elasticity, to understand stress, I need two things, force and area. Because I have just told stress is like pressure. So I need force and area. How in elasticity I explain you stress? See students, this is a metal wire or any elastic material. This is its area of cross section delta S, which was like this, but on the application of the force, these are the forces which are acting, it's slightly inclined as I'm pulling it. This delta S, which was originally like this, is deformed.
Deformed.
By the force F. This can be resolved into two components. One is the normal component and other is the tangential component. Ft is the tangential to the surface and Fn is the normal to the surface. Now, this material, cylindrical material, which is elastic in nature, is experiencing altogether two types of stress. One is normal or longitudinal stress. It is represented by sigma n. I am not saying that sigma n you should use what your honorable teacher in your school or in your textbook is using the word. But I am using here sigma n. What is sigma n? That is the normal or longitudinal stress, and it is normal force upon area. Correct? Second is tangential stress, which acts tangent to the surface. So, sigma t is Ft upon delta S. Students, longitudinal stress or normal stress is further of two types. If it is increasing the length, it is called tensile. If it is decreasing the length, it is called compressive. Tensile brings increase in length and compressive brings decrease in length. Any question?
No.
Is it all clear?
Yes, sir.
Now, my dear students, I am using very simple English because some of the students comments that sir put lectures in Hindi too, and if we have got a Hindi audience increasing, kindly comment, right? I'll start separate Hindi channel for them, right? Because our lectures are being appreciated across border too, in US, in Canada, Philippines, right? And we see that we have got so many queries from them. The people prefer to learn in English. If you people want in Hindi or Urdu, then we can start a separate channel for that. And kindly, Hindi audience or Urdu audience, give your comments. I'll start for that. Now students, stress is clear. One more stress I'm going to explain, that is volume stress. Which stress?
Volume stress.
See, what is volume stress? Suppose we people have got a kind of material like this. This is the uniformly shaped material, and you know, if on this material we are applying the force from all directions, right? So there is decrease in volume or increase in volume. Okay, with a decrease in volume or increase in volume, right? On account of what? The decrease in volume or
Increase in volume.
is on account of what? Volume stress. And volume stress is equal to force upon area. But this is what? The surface area of this spherical body, right? And we represent it with sigma, right? The volume stress we represent it with sigma.
Sigma.
And this is sigma V, we can call it. This is sigma V. You know, students, when you inflate a balloon, it's increasing in size, volume stress. Or you have a ball, plastic ball, and you compress, it has got a volume stress. Any question?
No.
Volume stress brings about change in volume. Tensile stress brings about increase or in length. Compressive stress brings about decrease in length.
Length.
Right? These are the basic definitions. Any question? Thank you.